welcome to this geometrics class. My name is Euclides and I am the father of geometrics. Today I'm going to teach all of you my latest discoveries, which can be found in my latest book, Elementa.
But Professor, what is it about?
Yes, my dear student, as I was about to say, in Elementa I have collected all my discoveries concerning geometry.
What? Is it all yours? You really discovered everything on your own? I mean, Elementa is really thick.
Yeah, because I heard that you just collected all the facts discoveries and put them in a book and sort of stuck your name on it.
Kolla, see! It's lies, it's all lies! Elementa is all mine! Well, let's start with similarity, shall we?
But what is similarity anyway?
It's when two objects have the same relationship between angles and sides. Basically, they have the same shape but not the same size.
Congruence in triangles. The meaning of the word congruence is that corresponding sides and angles are the same, i.e., the two figures are identical. There are three different ways to prove congruence in a figure. The first is that all the sides are the same. The second, that two sides and the angle between these are the same. The third and last way to prove this is by showing that two angles and the side between these angles are identical. If you want to show that, for example, two triangles are congruent, you write it like this.
Two triangles are similar to each other if they have the exact same shape, but not necessarily the same size. If two angles are equal between two triangles, they are similar.
Moving on, we are now going to talk about the top triangle theorem. The definition of a transversal is a line that cuts across two or more usually parallel lines. In the figure in front of you, the line AB is a transversal. It cuts across the parallel lines of PQ and RS. If it crosses the parallel lines at the right angles, it is called a perpendicular transversal. And if you carefully adjust A or B, you can create this type, which is just called a transversal. And now that we know what a transversal is, we can go on to explain the top triangle theorem. The top triangle theorem tells us that the top triangle, triangle ADE, is similar to the whole triangle, triangle ACB.
To prove the top triangle theorem, we must show that the triangles ADE and ACB are similar. From the definition of similarity, follows that if two angles are equal between two triangles, they are similar. We know that the angle A is common for both triangles. Since the transversal DE is parallel with CB and the line AB cuts DE and CB with the same angle, we know that the angle AED and ABC are equal, since they are corresponding angles. Since two angles are similar between the triangles, it means that the rest of the corresponding angles in the triangles are equal. Therefore, the triangles are similar.
The core theorem states the following. When two chords intersect inside a circle, the products of their segments are equal. To understand this, we first have to know what a chord is. The blue line is called the chord of the circle C. A chord is a line segment that connects one point of the circle with another. A chord that passes through the center of the circle is also the diameter of the circle. As you can see in the picture, the chords AB and PQ intersect and the products of their segments are equal. This means that A times B will be equal to P times Q.
Using the intersecting chord theorem, we are now going to solve the problem in front of you. 4 parenthesis x plus 1 equals 5 times 8, which gives us the answer x equals 9.
Triangle angle bisector theorem. In general, to bisect something means to cut it into two equal parts. The bisector is the thing doing the cutting. The bisector of an angle is the line passing through the vertex, point G, of the angle that cuts it into two equal smaller angles. In the figure above, JK is the bisector. It divides the larger angle, angle LGM, into two smaller equal angles, angle LGK and KGM. An angle bisector, line AD, of a triangle divides the opposite side in two pieces that are proportional to each other, creating the following relationship. BD divided by DC equals AB divided by AC. Using the triangle angle bisector theorem, we are now going to solve this problem. We have a triangle where we want to know the value of x. Following the theorem, we have 37 divided by x equals 45 divided by 31. And that gives us the answer to x as 25.49. And now, student, my dear friend Thales is here to give you a great reality-based example concerning similarity, and he'll be working with a pyramid that's very big. Thales or Philismu, please enlighten us.
Hello everybody, my name is Thales of Miletus and I'm here because my friend Euclides wants me to show how similarity can be applied in real life. So, open your ears, because I'm going to tell you a story. I was in Egypt at that time. I was enjoying the sun, taking baths, and having a great time. Until one day a thought stole away my peacefulness. How tall is this pyramid that is casting a shadow over my pool? Nobody could answer my question, so I did it by myself. I thought long and hard, and I found a very brilliant and simple solution. And this is my solution. I pushed a stick into the ground, and I thought that when the shadow of the stick was equal to the length of the stick, then the shadow of the pyramid would be equal to the height of the pyramid. So I measured the length of the shadow of the pyramid, and I got the height of the pyramid.
How thrilling! I really enjoyed it. I hope you learned a lot.